Before we look into how to use root from the scipy library, we save our file under a new file name and tidy away things we will not be needing. To demonstrate how root works, let's say that we want to solve the equation system 0 equals x plus a times b, 0 equals z times x minus b, and 0 equals y plus x divided by a for a equals 13.8 and b equals 3.2. To use root, we need to write from scipy.optimize import root at the beginning of the file. Root and its help is now available to us. We see that it uses a range of arguments, some of which are optional. We will only be needing the first 4 in the compulsory task on evaporation. The first argument is the name of whatever function we want root to solve. Let's call it our function. The second argument is the initial guesses of the solution as an ND array. Let's call it guesses. The third argument is a tuplet of things we want to pass on to the function. Let's call that other arguments. The fourth argument is the method. We will use the hybrid method hybr. As we now have 3 unknowns, x, y, and z, we need to put guesses of all 3 into an ND array. ND arrays are supplied by the NumPy library, so we write import numpy as np at the top of our code. Let's guess that the solution of x, y, and z are all 1, so we can write guesses equals np.array parenthesis bracket 1, 1, 1 bracket parenthesis. Well, it should be 1, 1, 1 to correctly define an NP array. If our guesses are bad, or if our equation system is difficult to solve, root will fail, but we'll have to see about that later. Let's say that we want to pass the values of a and b to our function rather than having them inside our function. We then put them together in our tuplet, other arguments. Now we need to create our function. Our function needs to have the array guesses as the first input and then our arguments for the values we wanted to pass to our function. We don't have to call them a and b in our function as long as we keep track of what we're doing. So we write def our function parenthesis guess comma a comma b parenthesis colon. In the compulsory task on evaporation, we strongly encourage you to translate the vector of guesses into something more easy to understand. So let's do that here as well. X, y, z equals guess. Then let us look at our equation system. Instead of the zeros on the left side, we need to put the result into a vector that we can return to the caller. Let's call that vector res. Since it should have the same size as our vector guess, we can initialize, for example, by writing res equals guess times 0 minus 1. Why the minus 1? Well, if we make any mistake in writing our equation system, for example, if we happen to write res 0 on all lines, like this, we don't want our function to return a vector of zeros, since a vector of zeros is a sign that we have found the solution. If you, like me, are used to programming languages like MATLAB or Fortran 90, a common mistake is to forget that in Python, as in probably a majority of programming languages, the first position of a vector is position 0. Okay, now let's just write return res, and our function should now be complete. Oops, we have an error here. Undefined name z. Well, that's because I accidentally wrote x, y, x rather than x, y, z up here. Okay, so what is the output of root? Well, the help on root states that it is an optimized result object with 3 important attributes. X, the solution array, success, a Boolean flag, was iteration successful, and finally message, a description of the cause of termination. Let us store the result of the call of root into a variable sol, and after the call test if sol.success is true, in which case we write sol.x. If sol.success is false, we print sol.message. When we run, we see that we get our result as an array, -44, 3.2, and -0.07. As we inside our function define the order to be x, y, z, then x equals minus 44, y equals 3.2, and z equals minus 0.07. Let's try to break our code by typing in res0 twice and omit res1 in our function. When we run, we now get the message the iteration is not making good progress.